so this is like your sort of Joe average air microphone, right? This is a small one. This is a fairly old lavalier microphone, which is what the news reporter used to wear when you do an interview or something like that on the street. So it's a miniature microphone for its day, which was sort of maybe the very early 60s or something was when this thing was made. But this is what we call, in sort of very exact terms, an air microphone. Its job is to pick up vibrations in air, and it does it reasonably well. When I talk near it, it does a reasonable job of picking up the vibrations in the air. And that's pretty much its best function. It's also capable of re-picking up vibrations. So if it's placed very near its reproducer, it sort of creates a loop and starts to generate sound by itself, which is something that we do all the time in electronics, whether we know it or not. We're constantly making feedback. This is the commonest type of microphone, and they usually take a form very much like this, or the handheld thing that the interviewer does. Hey, you, what do you think? This is what I think.
That's called an air microphone?
Yeah, and sort of very... Usually they just refer to it as a microphone,
Yeah.
but specifically it's an air microphone because it operates in air, most people take for granted. And it's also, this one is what we call an electrodynamic microphone, which is to say the principle by which it works is almost identical to the way that this thing works. You guys all recognize this thing? This is your sort of average, cheap 3-inch loudspeaker. Over here is the loudspeaker that we're listening to most things through, which is a fairly large PA speaker, maybe about 15 or 12 inches across. But it's very similar to this sort of tiny job as well. This thing operates on exactly the same principle as the air mic. It just operates in reverse. Okay, so what this thing does is it takes vibrations in the air and collects them through a membrane, something like this, right? Like a drum head, very much like the eardrum, right? And it generates a very small electrical current that passes through numerous amplifiers to sort of fortify the signal, make it larger and more strong, until it's got enough power to actually push another diaphragm around that looks remarkably like the one that generated the sound in the first place, and then push the air around. Does that make sense? So every time, you don't see them unless the vibrations are very low in frequency, but it's actually moving, the cone of this thing is actually moving in and out, 20 times a second if it's reproducing a tone that's 20 hertz, the lowest one we can hear, or 15,000 times a second if it's reproducing the sound that's the highest that we can hear.
So if there was like a really loud sound at that, could that pick it up? Like a microphone?
Yeah, well, you want me to see if I can make the cone jump? Is that what you're asking?
I mean, can you make a little sound come out of that and have a loud sound go in there? You know what I mean? Would that function backwards if it was...
Yes, yes. What I'd like to demonstrate sort of a very simple way is that this is perfectly adequate as a microphone as well. We'll sort of do that demonstration very quickly. Where's the wire that feeds it? Okay, so we plug this in. Okay, so if you want to talk into that.
Hello?
Right, so it's a kind of a crummy microphone in a lot of ways. If it buzzes like, don't worry about it. So this is sort of the sort of easier way to look at what's in a microphone is you've got this sort of diaphragm, and if I push the diaphragm, I'm generating a very slow signal. Right here we've got what we call an oscilloscope, which is a device for looking at electrical vibrations too. So every time I make a change in the electrical vibration, it also is sort of reflected by the movement on the screen. So as I push very slowly, do it very slowly, right? We see that we get an excursion in the screen sharpness. Sorry, see you later. And so this functions reasonably well as an air microphone, but it doesn't have what we think of as high fidelity, right? It doesn't reproduce every sound well. We would call this like a tinny kind of a microphone. It doesn't do a very good job of that. If we, if we want to make a bass microphone, which we do sometimes, we can actually take a larger loudspeaker and turn that into our microphone. people do that sometimes when they record bass drums. You'll see somebody make a bass drum mic out of something like this, and they just tape it to the bass drums.
Yeah.
It's sort of a super cheap shit way of making a bass drum mic. Works perfectly well. And then you don't pay a fortune for some bass drum mic either. So these things can sort of operate in reverse, right? This thing is ordinarily used to push the air around, but I can also use it to collect signals. And you can do that with an awful lot of microphone types, which I'll demonstrate to in a minute. We call this an air microphone because its job is still to push around the air. But there are sort of numerous other ways in which we get sound. Oh, sorry. For instance, we very often hear sound through surfaces, right? Microphones of this type, where is one? This is another kind of a microphone that we call a contact microphone. Okay. It's very tiny. If you want to get a closer look at it, you probably should stand up and look at it. But it looks sort of shockingly simple. On the end of the wire, there's just this little brass disc and a couple of wires leading to it. Inside the contact microphone is something that looks like this. This one's coated in a sort of rubber coating. But this is the main ingredient in a contact microphone, which is a simple brass disc with some of this crystal crap coated on top of it. Okay, you can buy these sorts of things at from mail order dealers or Radio Shack.
You mean the crystal stuff, some clear shit on it?
It's this little rectangle of junk on there.
That's crystal?
That's a kind of what's known as a Piezo-Electric Crystal. You sometimes see these things referred to as piezo mics.
Yeah.
You ever heard that term? Contact mic is the general term. But what's unique about this kind of a mic is that it hears better through its surfaces than in any other way. So if I sort of hold it up to my mouth and whisper, you know, if you want to catch someone's attention, whisper. It does a crummy job of being a microphone in that way. But if I touch the surface at all, it sort of comes alive. So it really can only hear through its surfaces. Every time this piece of crystal itself, if you want to pass that around, you can. Every time the piece of crystal itself changes its shape ever so slightly, it generates a small electrical signal. And that's the only way that it operates. So if I take this sort of very noisy mic and I sort of tame it by touching it to the table, and I knock on the table over here, I'm amplifying the entire table, right? And this works remarkably well for acoustic instruments. If we take this guitar, we can simply jam the microphone somewhere up, right? And this is the principle by which the average acoustic guitar pickup works. It's basically a piezo disc, and this works absolutely best when plugged into the bridge because that's where the vibration actually exists. Like for your dulcimer stuff, that's where you'd be putting your contact mics probably.
Can you make one of those fairly easily?
Yeah, the ingredients cost about 50 cents.
So the crystal stuff, where do you find them?
Yeah, well you buy them coated onto these discs. They're referred to as piezo discs. You can buy them in Radio Shack. You basically solder wires to it.
That's just P-I-A-S-O?
P-I-E-Z-O.
Oh.
The word it comes from the Latin word for pressure. So it changes when pressure is applied to it. It generates an electrical signal. These things work equally well. You can buy them at Radio Shack or through a mail order dealer. And you basically just have to solder wires to it, and it makes a fine pickup for just about anything you want.